All right, these problems are called numerical derivatives because after taking a derivative for these questions, you then plug in numbers and calculate the answer numerically. So for this first problem, part A, h of x is defined to be 3 times the function f of x minus g of x. So the rules that we're going to be using for this derivative here are the constant multiple rule, which tells us that this 3 multiplying f of x will simply stay there and multiply our derivative of f, written as f prime of x. Next, we're going to use the difference rule, which is actually really simple. You just put that minus sign there, and we take the derivative of g, which is g prime of x. So now that we've taken our derivative, now let's actually plug in 5 into our derivative, which really means we're going to be using these values in the table. 3 times f prime, which is here, which is 4, minus g prime of x, which is here, negative 3. So now this problem just comes down to, can you calculate it correctly, which is 12 plus 3, or in other words, 15. For this second problem, we're going to need a much different derivative rule than the sum or difference rule. If you notice for part B, h of x is defined to be 6 f of x times g of x, meaning that h is the product of two separate functions. In problems like this, I try to establish which function I'll consider my first function, in this case 6 f of x, and then which function is going to be my second function, which in this case would be just g of x. So in order to find this derivative, h prime of x this time, we use the first function, 6 f of x, times the derivative of the second, which is g prime of x. Then we add the second function, g of x, times the derivative of the first. The derivative of 6 f of x, by the way, is 6 times f prime of x. So notice we had to use the constant multiple rule there. Now that we've taken our derivative, here's where we can plug in 5, which really means we're going to use our values in our table again. So 6 times whatever f of x is going to give us, times g of x, plus g of x times 6 times f of x. Whenever you do product rule problems, please take a look at all 4 of our values in this table. Each one is going to be used. So to start out, f of x is 6. G prime of x is negative 3. G of x is negative 1. And f prime of x is 4. One good way to make sure that you know you've done the product rule correctly in problems like this is to double check that you've used all 4 of the values at least once. That's generally what happens with these types of questions. So now when we calculate, we have 2 different terms. This one here is 6 times negative 3, which turns out to be a negative 108, plus over here we have negative 1 times 6 times 4, which is a negative 24. If you add these 2 negative numbers together, you get a total of negative 132, which is the answer to this question. Sometimes using the product rule can be a little bit tricky, especially when there's constant multiples like the 6 in this question. So oftentimes people will find another way to use the product rule that simplifies this process. Instead of treating the first function as 6 f of x, what if we just considered f of x, the first, and g of x as the second, and considered that this 6 is simply a constant multiple? In my opinion, this makes the problem a lot easier to work with because now, let me just keep this 6 out of here. And now when I use the product rule, I can simply use first f of x times d second, g prime, plus second, which is g of x, times d first, which is f prime of x. Now if you notice, compared to the way we did the problem before, the results will still be the same. The 6 is going to multiply both of these terms eventually, but in this method, we can save the 6 for later. So in this question now, it simply becomes a matter of finding these 4 numbers from our table like before, adding them up, and then multiplying by a 6. So what are the numbers we'll use? For this question here, we have a 6 and negative 3 and a negative 1 and 4. Now watch how the calculation actually is easier now if you treat this as two separate problems. 6 times negative 3 is negative 18, plus negative 1 times 4 is a negative 4. So now we have 6 times the quantity, negative 22, which still gives us the answer of negative 132. In my opinion, this makes the problem so much easier because now this 6 isn't used until the very last step when you're multiplying really the product rule in the parentheses. For part C, we're given the function h of x equals f divided by g, making h of x a quotient of two other functions. So when you're trying to find the derivative of a quotient, here's where we would use something called the quotient rule. For problems like this, I try to establish which function is considered the high function and which function is considered the low function. This helps me because when I take these derivatives, I take the low function times the derivative of the high function, d high. Then I subtract minus the high function, f of x, times the derivative of the low, g prime of x. Finally, you can square the bottom function, g of x, and square it, and that gives you the derivative of a quotient. So now, once again, this problem comes down to whether or not we can get the correct answer by plugging in the correct numbers. So for quotient rule problems, once again, we're going to need 4 numbers to be used, and all 4 numbers in the table will get used at least once. Then in the denominator, we're going to have to take a value and square it. So what goes where? Well, g of x represents our low function, so there's negative 1. That goes for g of x there and in the denominator. Then we'll take f prime of x, which is 4, plug it in for f prime. Then f of x gives us a 6. Finally, g prime of x is negative 3. So again, with these types of questions, just double check to make sure that you used all 4 of those numbers in the table at least once. So now the question comes down to calculating correctly, as it always does. So we'll get a quotient of negative 4 minus a negative 18, all divided by a positive 1. That'll give us a negative 4 plus 18, which is actually going to give us a 14 divided by 1. So of course our final answer is 14. And if you want some practice with numerical derivatives, here are 4 new values of functions and their derivatives, and 3 new functions for h of x. Try using the sum and difference rule, the constant multiple rule, the product rule, and of course the quotient rule for these 3 problems. Check the comments for your answers.